Welcome to Algebra 2 Review, Exponents and Logarithms. We will cover the odds in this video. Number 1, it says, rewrite each equation in exponential form. So we will be rewriting in exponential form. That means it will contain exponents in this form of bx equals y. Number 1, your base is of 15. So 15 to the negative 2 is equal to 1 over 225. There's your solution. Number 3, your base is a b. So this one will be b to the 11 is equal to a. And there's your solution. You are just rewriting it. We're not solving. We're not evaluating. Number 5 and 7. This time you are going to rewrite it in logarithmic form. That means you will contain logs. Okay? Just rewriting it, kind of like writing penmanship. All right, so you're going to have your log. It's always in this form, log base b, y equals x. That form right there. So your base is 11 of p is equal to negative 6. Number 7, log base of 16, x equals y. Okay? So you're basically saying 16 to the y is equal to x in that order. Number 9, you are going to use your calculator to approximate each to the nearest thousands, and thousands has 3 decimal places right there. Okay? So on your calculator for number 9, all you're going to type is your natural log, which is next to the 4, and type 4.1 and round your answers. This one comes out to be approximately 1.411. Okay? Number 11, if you will notice, this is a negative. You cannot have a negative there, and so you will write undefined. No real answer. So just use your calculator to help you on that part. 13, this time we are going to evaluate, okay? Either use your yellow or pink sheet to kind of help you, and this is how you can work through the process. Basically, you can say 7 to what power is equal to 343? Well, 7 to the third power is equal to 343. 15. Notice you have a fraction. If it's a fraction, this is the same thing as 9. Here's the first to the negative 1. Okay? So you ask yourself, 3 to what power is equal to 9? Well, 3 to the negative 2 will give it 1 over 9. 17. Notice you have a negative again. So your solution is undefined. Cannot have a negative there. But if you have a fraction, you're going to have a negative exponential. 19, condensing. That means you're going to write it as one single logarithmic value. So use your green sheet to help you. Condense, we're going to write it as a single logarithm. First of all, move the 6 over and move the 4 over. I will show you step by step. Some of you will skip some of these steps, and that's okay. So you're going to have log base 3 u to the 6 minus log base 3 b to the 4. Notice that's a minus, corresponds to a minus, and to condense it is a division. Same base, notice the base are the same. So log base of 3, same thing as u to the 6 divided by v to the 4th. And you can put parentheses around it if you like. There's number 19. Condense, write it as one log, and I have one log written here. Number 21. Remember, we want to write it as one log, okay? This here is the same thing as 1/2. So what you can do is, you can rewrite it as 1/2 log base 5 to the u plus 1/2 log base 5 to the v plus 1/2 log base 5 to the w. One thing you need to be aware of is this. Remember, a square root of x is the same thing as x to the 1/2. Just refresh your memory. Notice how these are all pluses right here. What corresponds to plus is multiplication. So first off, I'm going to move this over. It becomes your exponential. Okay? So now you have log base 5, u to the 1/2, times v to the 1/2, times w to the 1/2. Rewrite it to make it look pretty. Log base of 5, I'm going to write it in radical form. So u times v times w. Okay? Just like that. Or you can write it u times v times w parentheses to the 1/2. Both of those are going to be correct. Number 23, same thing. Move your u over, move the 4 over. We're adding, so adding would be multiplication. So log base, notice it's a base 10, u to the 16, v to the 4. Okay? Just like that. So you move it over, you multiply like base, understood to be a 10, you don't have to write that. 25, we're going to go in reverse order. Now we are going to expand, okay? Notice this 3 goes to both the a and the b. So we're going to have log written more than one time. So log base of 4, a to the 3rd. Notice it's a multiplication, so you're going to add log base 4, b to the 12th, okay? Bring your powers to the front. So now you have log base 4 to the a plus 12 log base 4 to the b. And there you have expanded. 27. Remember what I said, a square root of x is the same thing as x to the 1/2. Okay? Here you are multiplying. What corresponds to the multiplication in logarithmic property is addition. So you want to expand, so log's going to be written 3 times. 1, 2, 3. Log base 2, a to the 1/2, plus log base 2, b to the 1/2, plus log base 2, c to the 1/2. Okay? Rewrite it, bring it all to the front. So log base 2a over 2 plus log base 2b over 2. Remember, it's the same thing as 1/2 in the front, plus log base 2c over 2. And you have expanded your 3 logs. Number 29. Okay, expanding, same thing. That means log's going to be written twice, 1, 2. Okay, so log base 6, x to the 5th, plus log base 6, y to the 6. Bring your powers to the front. 5 log base 6x plus 6 log base 6y. There you have your solution. Okay? Number 31. Here we are going to start solving. So here's your solution. Okay. Every one of these will be a little different depending on what problem you are working on. All right? Now take a look. This group right here goes with that log of 8. Remember, multiplication is the inverse of division. Addition is inverse of subtraction. Logarithm is an inverse of exponents, and vice versa. So keep those things in mind. Okay? So first of all, I'm going to subtract 3. What you do to one side, you do to the other. So now you have log base 8, negative 3x minus 1 is equal to negative 1. Get rid of your log. So what is that going to be? I'm going to write it as my exponent. So you're going to have 8 to the negative 1 is equal to negative 3x minus 1. I will draw my little arrow. Some of you can ignore it, but it might help some of you. So there you have, okay? That should have been 8. All right, right there. All right. 8 to the negative 1 is the same thing as 1 over 8 is equal to negative 3x minus 1. To get rid of your fraction, you multiply both by 8. See how that cancels? So 1 is equal to negative 24x minus 8. Okay? Continue on. I'm running out of room, so I'm going to write it up here. Add 8 to both sides. What you do to one side, you do to the other. So 9 is equal to negative 24x. Divide by negative 24. What you do to one side, you do to the other. So x is equal to negative 9 over 24, which is negative 3 over 8. Solving x equals something. Okay? Number 33. Okay? This time you have a 9. 9 times the natural log. Now keep in mind, natural log is the same thing as log with the base of e. So first off, I'm going to divide both of them by 9. So you have natural log 1 minus 2v is equal to negative 2. Remember how natural log is the same thing as e? Okay? So some of you will rewrite this. I will do it for this one, but the others I probably won't. Remember, natural log is the same thing as log base e. Here we go again. E to the negative 2 is equal to that. Use your inverse property. So e squared, by the way, that should be a negative. So this should be a positive. My apologies. Okay? E squared is equal to 1 minus 2v. Yeah, there's a negative right here that we didn't see. There's a negative here. All right, remember, keep in mind what you're solving for, v or e. I'm solving for v, so I'm going to subtract 1. So e squared minus 1 is equal to negative 2v. Divide both sides by negative 2. v is equal to e squared minus 1 divided by negative 2. Okay. 35. This is 3 times the log of that. So I'm going to divide both sides by 3. So you have log base of 5. b minus 7 is equal to 0. Okay, take the inverse of log. So 5 to the 0 is equal to b minus 7. Anything to the 0 power is 1. So b minus 7. Add 7 to both sides. So b is equal to 8. Okay? Do check your answers as you are working some of these problems. Okay, for example, let me show you how to check for number 35. On your calculator, just like that, okay? We want it to equal 0. So type in 3, alpha window, 5. Your base is 5. B is 8. So what is 8 minus 7? See it right there? Okay? Equal 0. You see how that's 0? So this one works. That's all you have to do to check. So I just typed it in like I saw it and replace whatever that is. All right, 37. Here we go. Look at this right here. This is negative 4 plus the log of that. So opposite of positive 4, negative 4 is positive 4. My apologies. Okay. So now you have log base 3 negative 6p is equal to 0. Use your inverse property. 3 to the 0 is equal to negative 6p. Anything to the 0 power is 1 equals negative 6p. Divide both sides by negative 6. P is equal to negative 1 over 6. Check your answers, okay? There's number 37. Number 39. All right. Now we're going to use the law of logarithmic properties to help us right here. I can't cancel logs out because that one does not have a log. Okay, but however, you see this minus right here? What corresponds to a minus in logarithmic? It is division. Same base. So log base of 3, x plus 4 divided by x is equal to 2. So I'm condensing it because I'm more familiar with that. Now, use your inverse property of logs. So you have 3 squared is equal to x plus 4 divided by x. Okay? You cannot cancel out these x because you got a plus 4 there. 3 squared is 9. X plus 4 divided by x. Get rid of your fraction. Opposite of dividing by x is times x. What you do to one side, you do to the other. So now you have 9x is equal to x plus 4. Solve. Subtract x on both sides. 8x is equal to 4. Divide by 8. Divide by 8. X is equal to 4 over 8, which is 1 half. Okay? 41. Give that to you a moment. There you go. Okay. Number 41. If you'll look, you see how they all contain natural logs? But keep in mind, you're using those properties. So since all your terms contain natural logs, you can cancel them out. But don't forget about that property right there, okay? So I'm going to rewrite this as x plus 7, that corresponds to a minus is division, is equal to 67, just like that. And I can do that because all of them have a natural log. Now multiply both sides by 2. X plus 7 is equal to 134. Subtract 7. X is equal to 127. Okay? And there you have number 41. 43. Now, you can't do like you did on 41 because that one doesn't contain log. But you can go back to number 39 and check, okay, to help you. All right. See that net minus right there? We're going to condense this. We're going to write it as one log term because the bases are the same. So log base of 8, 4x squared divided by 2 is equal to 3. All right? Some of you will simplify right here. Some of you will not. I'm going to go ahead and simplify. So you have log base 8. 4 divided by 2 leaves you 2x squared is equal to 3. Use your inverse property of logs. So this is 8 to the third is equal to 2x squared. Cannot divide by 2 yet. Okay? Go to your calculator. What is 8 to the third power? 512 is equal to 2x squared. Divide both sides by 2. X squared is 256. Square root that. Anytime you square root, you have two answers. So x is equal to positive 16 and negative 16. Now, you have got to check, okay? Use your calculator to check. So, let's check, see if they both work. Here we go. All right. First one, we're going to try negative 16. If I know negative 16 works, positive will work too because that's a square right there. So alpha window, number 5, 8, right click to 4 parentheses, negative 16, in parentheses, square. Okay, see that right there? Minus alpha window, number 5, 8, right click to 2. Okay? Okay, I must have messed up somewhere. Let's check this again. Oh, that should have been a 4. My fault. Let's try this again. Alpha window, that's not it. Let me get out of that, please. Okay, alpha window, number 5. This should be 8, right click. That should be 4 parentheses, negative 16, in parentheses, square, right click. Minus alpha window 5, okay, that's 8, that's a 2. See how it comes out to be 3? That works. So since they both work, it's going to be fine. If I had a positive 16 there, anything squared is positive, so that's going to work, okay? So they both work for number 43. All right, number 45, we are going to graph. You got to list all these things. You got to find the vertical asymptote, domain, range, state the 5 points, and then you got to sketch. So those are things that I need from you guys. Okay. Take a look at your transformation chart if you need to. Positive 5 inside parentheses, you're going to move left. It's opposite of what you always think because it's x minus h. Plus 2, we're going to move up 2. Okay. First off, sketch your asymptote. So, BA, x is equal to, you see how this is a positive 5? It will be a negative 5. So go to where x is negative 5 and draw your dashes. This is the line that the graph is going to approach but never cross. Okay? Next part. Remember, we always start at 1, 0. So you could have gone ahead and count 5 to the left. 1, 2, 3, 4, 5, up 2. Okay? Just like that. Or, if I were you, I would go to y equal, and I would type this in. So, alpha window, alpha window, let me get out of that real quick. Y equal, okay? Alpha window, 5, base is 2, right click, x plus 5, right click, plus 2, and hit graph. This kind of tells you what your graph is going to look like. Okay? Now, from there, you could write your 5 points. Go to second table. Scroll until you see where the word error comes in. Do you see how your first error? -5. That's your asymptote. Now, write the next 4 points after that. -4 and 2. See it right there? Okay. -3 and 3. -2, 3.6. -1, 4. And your very last point, please look at the graph. I always want to see where it goes out right here. 8. Scroll down to 8. Okay? When x is 8, it is at 5.7. And there you have your 5 points. Okay. Go ahead and plot these. 4 and -2. See how you found that first? -3, +3. -2, 3.6. -1 and 4. And your last one here, 8, is at 5.7. Connect your point. Draw your arrows. It is a graph that continues on. Add your tail. Notice it's approaching your asymptote, but it never crosses. Okay? So you've done all those things. Now let's find our domain. Your domain, where does it start? -5, parentheses, because it does not include it, to infinity. Your range will always be all real numbers in logarithm. 47. Okay? Let's graph 47. Same thing. We're going to move to the right one, and we're going to move down. Okay? Just like that. Vertical, asymptote. X is at 1. Draw your dashes. Okay, there's my dash. Go to your calculator. Type that in. Okay? Y equal. Clear that. Alpha window, 5. 4, right click to x minus 1. Right click to -5. Make sure you write -5 and not -5. Now hit graph. Kind of gives you an idea what your graph's going to look like. Notice my window is set to 5 and -5. Not a big deal. Okay. Scroll until you see error. You see how that one is error? There's your asymptote right there. Write the next 5 points down. 2, -5. 3, -4.5. 4, -4.2. 5, -4. And my last one is an 8. That kind of just gives you a sense of the curve. So it's a -3.6. Okay? Plot your points. 2, -5, right here. Or you could have gone right here, gone 1 right, 5 down. See how that matches it? 3, -4.5. 4, -4.2. 5, -4. And that last one is 3.6. There's your graph. Add your tail. Okay? Domain starts at 1, continues on forever. Your range, all real number every time. And that's number 47. All right. Now I want you guys to go to the page that I added for you for the review. Okay? We're going back to solving. Here's a different method. It says round to the nearest 10,000ths. If you will make it round to 1,000, I will be just fine, but we're going to follow the directions here. All right. Remember how addition, inverses, subtraction, multiplication, division, exponential is logarithm? We're going to use that to help us. Notice the location of the R. We're solving for R. Where is R? R is your exponent. Since I'm solving for exponents, I'm going to use logs to help me. So, remember, b to the x is equal to y, okay? Inverse of that is log base b to the y is equal to x. Notice how they work with each other. All right, so here's my base. So I'm going to say log base of 6 to 41 is equal to 6r. I got rid of my exponents by using logs, okay? And then solve. How do you solve for r? Well, you're going to divide both sides by 6. That cancel, so r is equal to. Go to your calculator. Okay, I'm going to spread up some more so you can guys see my calculator. Let me get out of that. Okay, so you're going to type alpha window 5. 6, right click to 41, just like that. Divided by 6. Do you see that part? And that's all I did, okay? Divided by 6. All right, so since you did that, right, equal, we're going to round it to the nearest 10,000s. So r comes out to be 0.3454, okay? 4 zeros. There's number 1, just like that. So use that to help you. All right, number 3. Next part, r is in the exponential. So I want to get rid of my exponents. To do that, I'm going to use log. Here's your base, okay? Log base of 7 of 1 is equal to r minus 4.4, okay? How do you solve for r? You add 4.4. What you do to one side, you do to the other. So r is equal to, type that on your calculator, alpha window 5, just like that, okay? So we're going to put a 7 here, right click to 1, plus 4.4. That comes out to be 4.4. And it says round to the nearest thousand, so I'm going to add zeros, 10,000s. There you have that. All right, next part, number 5, okay? Now this one, before you do anything, you need to get rid of that 2 first, so that way I have m by itself. Minus 2 minus 2, e to the 3m is equal to 94. So, now you're solving for m. Notice this is an e, so we're going to use natural log, or you can use log base, e. I'm going to write it as natural log base first. Well, I'm going to write it as log base e first, and then you can see what I do, okay? So log base of e, base e of 94 is equal to 3m. Now, log base e is the same thing as natural log of 94 is equal to 3m. Do you see that right there? Some of you can go from here to here. Solve for m, divide by 3. So m is equal to, use your calculator, natural log of 94 in parentheses divided by 3. That gives you 1.5144. Okay? So solving depends on the problem that is presented to you. Let's go to number 7. All right, so we're going to solve for each equation also. Okay? So if you look, you need your yellow sheet to help you. This one is a lot easier if you try to find the same base. But first of all, I'm going to rewrite this one. This here is the same thing as 216 to the negative 1 times 3p is equal to 36p. Notice, I am solving for both p, for p in the exponential position. So go to your yellow sheet, okay? 36, usually 36 is a 6, okay, if I square it. Now, you see how there's 36 right here, and you see how there's 216 right here. I am going to rewrite this. Instead of 216, 6 to the third, I'm going to replace it with. So 6 to the third times negative 3p is equal to 6 squared times p. Okay. So what I did was, instead of writing 216, I wrote it as 6 to the third, so I can have the same base. Instead of 36, I wrote it as 6 squared. Did you guys see that? So I'm going to use this little yellow sheet to help me. Now my base is the same. cancel those out, and I can set it up to solve. 3 times negative 3p is negative 9p times equals 2p. Okay? So let's add add 9 to both sides. 9p cancels out to give you 0 is equal to 11p divided by 11. P is equal to 0. Now, you can check, okay? So let's check. 3 times 0 is 0. Anything to the 0 power is 1. 36 to the 0 power is 1. So they both come out to be 1 equals 1. So that checks. Number 9. Now let's take a look. I'm banking since that 16 is probably a 4. So let's go to a 4. You got a 16 and a 64. Do you guys see that right there? So instead of writing 16, I'm going to write it with the same base. I want to use the base of 4. So 4 squared times 3b, you see that right there? 4 squared is the same thing as 16, equals 64 is the same thing as 4 to the 3rd power, see the 64, times 2b minus 2. Notice I have like bases on both sides. Cancel them out. 2 times negative 3b is negative 6b equals, distribute, 6b minus 6. Okay? Now I'm solving for b. So minus 6b, what you do to one side, you do to the other. That leaves you negative 12b equals negative 6. Okay? Divide by negative 12, you guys know the solving part. So b is equal to negative 6 over negative 12, which is 1/2. One answer. If you want to check, plug it back in. Okay? Number 11. Oh look, the base is already the same. Cancel those out. So you have 3x equals negative 2x. Add 2x to both sides. 5x equals 0. X is equal to 0. And they both work. Okay? That's the end for the odds. I will have the evens tomorrow.